welcome everyone to the hands-on seminar on digitalization of processes. Before I begin, I would like to mention that this webinar is going to be recorded. The recording has already been started. So if any of you would not like to be on the recording, please throughout the webinar keep your camera off and your microphone shut down, and then you won't be on the recording. And this webinar will also be available online on the website of A4G. So A4G is part of a cluster of multiple projects. On the left-hand side, we see the sister projects, and together they have formed sort of a forum called IA Impact. And on the right-hand side, we have some projects that are also ongoing, not sister projects, but very close to our activities, and we would like to mention all of them, and hopefully representatives of those projects are here. So we are happy to exchange information and learn from each other. So what is the webinar about? First, I will present the Institute. So my name is Yoav Nachshon, and my colleague here is Kiran Kamaswamy. And we are working in the Fraunhofer Institute for Mechanics of Materials, IWM, located in Freiburg, Germany. The Institute itself is focused on traditional research fields in material science, specifically materials modeling and characterization, or also assessment of components, manufacturing processes, and their parameters such as efficiency, lifetime are being considered. But more and more, digitalization plays a key role. And one of the focuses is to develop technologies specifically for materials and processes, and the goal is to generate distinctive added value through the application of data-driven tools, and part of those activities we will show today. So the webinar is what is our starting point? And the claim is that in material science and manufacturing, processes are fundamental. We have different kinds of manufacturing, if it's casting, or of processes. If it's in manufacturing, it could be casting, forming, in characterization. We have different methods, techniques, microscopy, spectroscopy, and so on. Modeling, we have different types of modeling. And also, more and more, we see how AI is being applied for the in material science. It could be materials discovery, and other activities such as digital twins to represent real life entities in a computerized environment. And the question that we are trying to answer throughout the webinar is how can processes be curated in an effective manner. We will discuss what it means effective, what are the current approaches, what are the drawbacks, and we propose a novel way to do it, and we argue that it brings lots of benefits. So the objectives of the webinar is one part is rather theoretical, gaining understanding of the importance of standardized and fair documentation, and we will explain what it means fair. And specifically, we're looking at processes. Today it will be characterization, but what we will show today can be extended to modeling and manufacturing. We will see the role of semantic technologies to achieve fair documentation, and we delve into the CHADA standard, which is a European initiative for documenting characterization processes. The second part will be to gain practical knowledge, and here we will invite the participants, you, to take part, to try out, and at the end we will ask you for feedback. So the agenda is as follows. This was the introduction and the objectives, and next my colleague Kiran will take over, where he will discuss the semantics management. Then I will talk about the process digital tool that we have developed. We then have a break for 15 minutes, and after that we have a hands-on session. And after that we have another short discussion, and that will be the end around 12, no later than 12, possibly before. Then with that, I would like to hand it over to Kiran for the next part.
Good morning, everyone. I am Kiran Kumaraswamy. I work as a software developer at Frona for IWM, along with Yob. I'm also responsible for the development of process digital tool and vocabulary manager tool, along with Yob. So in this presentation, I'm going to talk a bit about semantic data, more with respect to the CHADA, and then I introduce some concepts about the fair data and the role of ontologies, and finally I talk about our vocabulary, the development of our vocabulary manager, what exactly it solves, and finally I give some demonstration of our vocabulary management tool. So before moving to CHADA, let's start with some challenges, the motivation why we need CHADA. So there are several challenges in documenting the characterization process in material science domain. The first and the foremost challenge is the inconsistencies in experimental procedures. For example, a small variation in sample preparation can result in a drastically different outcomes in the experiments that we conduct in the material science labs. And also, there exists a lot of diverse modeling methodologies. Using a small different conditions or a solver settings in simulation experiments, it can result in a completely different reporting of material properties and also the misinterpretation of results. And the other big challenge is the lack of detailed protocol reporting. Most of the times, the publication often lack a detailed description of their simulation parameters or other parameters they conduct in the experiments. So usually this hinders the reproducibility of or the validation of these experiments by other end users. So because of all these, there is a significant impact on the collaborative research. So there is inconsistencies in the cross-institutional and interdisciplinary collaborations. To overcome all these challenges, we need a universally accepted standardized protocol to document the experiments in the labs. So like we need such protocols for both characterization process and also the modeling process. And two such processes are CHADA and MODA. CHADA stands for characterization document and MODA stands for modeling data. So in this presentation, we are just going to highlight about the CHADA, and we can keep the MODA for another webinar later. So what is CHADA? So as I said, CHADA stands for characterization data. CHADA is the outcome of Oyster project of Horizon 2020. So the main objective of CHADA is to harmonize the characterization process across experiments in Europe. So we want to develop a characterization platform which is built on semantic principles and open standards by which characterization process can be described and stored as data. So the main goal is we don't want to actually create a single platform which integrates all these semantic principles. Instead, we want one common language which will be used across different platforms. So the idea is we can develop as many semantic platforms across different projects, but these platforms utilize one common language. In such cases, we can enhance the reproducibility and interoperability of the data. So as I said, each European project can implement its own platform to store the metadata, but this metadata will be uh, represented in one common format. So one such common metadata format is characterization data. So in A4G Nest, our main goal from the Fraunhofer IWM as part of task 5.1 is to develop a digital tool which will use CHADA to store the characterization experiments. So the CHADA is revised under the CWA workshop with 17815 ID. This is a general representation of any characterization experiments that we conduct in material science domain. So we can classify all the experiments into one common representation, and this is how it looks like. So any experiments will have a specimen which is under test, and it will also have a probe to investigate the specimen, physical properties of the specimen. So the interaction between the probe and the specimen, which it generates a signal, and this signal will be detected by a detector. So later, these signals can be stored as a raw data, and we can also utilize this raw data with certain post-processing steps or data analysis steps to generate more elaborated data. So these experiments which we conduct in the labs, eventually we have to document in a certain way. So the more traditional approach of documenting is in a Microsoft Word representations where we try to bring all the experimental details we conduct in a paragraph of data or in a table format. So usually what happens prior to CHADA was, so each of us, when we conduct an experiment, we create our own representation of characterization of these experiments. And we wanted to bring one common format. So that is the CHADA. So as I said, without a common structures, it's really difficult to reproduce these experiments or share this experiment with others. So the idea is to bring one common format. Like it's always difficult to bring one common format to represent different kinds of experiment. The idea here is to have one generic structure which can be extended later depending on the kind of experiments or the domain. So this is how a common structure of CHADA looks like. So each characterization experiment will have basically 4 sections. So the first one is the user story. So the user story, it describes about the context or question, the issue to be answered by the characterization experiment. And the second section is the rationale behind or the justification of chosen methods within the experiments. So we can also specify the reference to an external publications or any standards. So why do we why do we choose these methods and why are we conducting these experiments? And then the third and the foremost important is the characterization workflow. So when we talk about experiments, again, as I said, I will go back to the previous slides. So when we conduct an experiment, there can be multiple steps associated within the experiments. For example, when we have a specimen, we will have like our sample, we will have a sample pre-processing step, we have a sample inspection step or a calibration step. All these steps can be classified under characterization workflow. So for each of these steps, we will have a separate documentation. So how did we do a sample inspection step? What are the inputs for the sample inspection step? And what are the procedures we followed? And finally, after sample inspection step, we will have an output sample. So similar to that, for each and every individual step, we will have a characterization experiment documented as a separate table. And finally, after an experiment, we will have a final outcome. So what did we achieve from the experiment? So there can be multiple results from the characterization experiment. So one can there can be multiple like measurement process steps within the experiment. So and we can have multiple outputs or results from these steps. So in the characterization outcome, we generalize and we bring all the results into one particular document, and we just describe what did we achieve, what is the final output or the results of this characterization experiment. So yeah, again, I already mentioned a lot about characterization experiments. So as I said, there can be multiple steps within each characterization experiment. Some of the core sub-process tasks are like sample definition, sample extraction, sample inspection, calibration, measurement parameters, and so on. And as I said, again, for each of these individual sub-process tasks, we will have a standardized documentations. So we have one table describing for each of these individual tasks. And each table will have certain information about what are the inputs we used for this task and the task details itself. And finally, what are the outputs we are achieving from this task. So this shows a BPM diagram, general BPM diagram for a characterization process. So here is an example of a documentation process. As I said, so the general representation of any like documentation approach of any characterization experiments using a Word format. So we create a separate table for each of these individual sections and also the subtasks, and we document. For example, as I said, we need to have a separate table for a user story. We need to have a separate material table for material systems, environment, operating conditions, rationale, and characterization workflow. Again, under characterization workflow, there will be individual steps. So previous to CHADA, I mentioned there was no structure followed. Each individual can have their own structure of documenting the characterization process. And it's a problem because we cannot reproduce or we cannot share it with others to reuse it. And then we brought this new structure called CHADA. And using the structure, we are forcing the individuals to create this documentation in a standard way with tables. And so that each individual will have a similar kind of documentation approach and it can be easily reproduced later. However, having this traditional approach, it has its own limitations. For example, creating the documentations in a Microsoft Word or storing it as a PDF, it has a limited accessibility and searchability. So if one person creates an experiment and store it as a Word format somewhere in a shared folder, like it's not so easy for another person to access this document and go through it. So it will be a hectic process to search the documents. And also, even though we have defined a CHADA structure to document this characterization process, there is no guarantee that each of the individuals follows this standardization. So there is no validation approach whether the individual followed the CHADA standardization. And also there is a poor data interoperability. So the document created by one person cannot be used by another person in another system to read this data. So, and then data fragmentation. So documents can be like, for example, instead of one single document, the entire procedure can be divided into multiple documents, and it's difficult to integrate and come to a conclusion with all the documents. And finally, the like another problem is the difficulty in version control. For example, if the structure of CHADA is changed in future for some reason, we add a new attributes or something, so it's not so easy to integrate it into the existing documents already created by the users. And also there is a loss of data and also the corruption of the file. So having said that, with all these limitations, the most critical part here is the traditional approach fails to store the data in a fair manner. So in recent days, in materials science domain and in each of the presentations, we talk about the fair data principles. So to highlight what fair data principle is, FAIR stands for findable, accessible, interoperable, and reusable, which means any data which we create, it has to be findable. So we can go to a web and we search this data, and it can be easily like searched and retrieved by a system. And also it should be easily accessible. For example, for each of the data we generate that exists, there should be a universal resource identifier through which we can navigate in the kind of any web browser, and we can identify this data uh, individually. Sorry. And then the data should be interoperable. The data created in one system can be easily accessed in another system, and also it should be easily understood by another system without any additional wrapper or human intervention to translate this data, through which a system too can be understandable. So, and finally, the data should be reusable. So the data which is generated by one process or a system can be easily reused, and it can be extended by another user or a system. So having said that, fair data, data which is fair doesn't mean the data has to be public. So the data can be fair within an organization itself. So for example, within a single organization, the data which they generate, so it can be findable, accessible, interoperable, and reusable within the systems of that organization. Finally, FAIR isn't just a buzzword. It's a framework to make data work smarter, but not harder. So yeah, this is about CHADA. So far, I hope everyone is following. And yeah, if anyone has some questions, they can also stop and they can ask. Okay, I see no one is asking. I hope then I will continue with my next set of slides. So, and I just mentioned about the data should be fair, but why is data still so hard to make it fair? The main reason is there are infinite combinations of representation of data. So the data can be represented in an Excel format. It can be stored in CSV format, or also it can be represented in JSON format, and so on. And each of this file has its own extension or structure or schemas. And most of the time, the data which we create in our process or experiments, it will be isolated. It is hard to find and reuse. And as I said previously, most of the times it will have incompatible formats. So data produced by one experiment, if I want to use it in a second experiment, if the data produced by the first experiment is not in the right format, which is accepted by the second simulation or an experiment. So it cannot be shared easily to shared easily. And most of the time, having data in an Excel format or a PDF format is mostly human readable and it's not machine readable. So again, a quote, in an age of AI and big data, most of our information is still locked in PDF, spreadsheets, and disconnected database. It's not just about storing data, it's about making it usable, shareable, and meaningful. So to solve this, what we believe is we need to have one common language, one common format, which can be easily interpreted by all the machines. So again, this is an introduction. The current situation is we have wide range of subdomains, large volumes of data located in multiple silos, and most of the time the data is heterogeneous. And the main biggest challenge is limited access to existing data, high amount of tailored solutions. So with all this, we need to have a proper documentation in order to share the data between the systems. So the main goal of having one common language and standard is to achieve interoperability and also the data-driven decision making. So what's the solution for having this one common language? So we believe it's ontology and ontology driven tools and having one common data documentation approach. So let's have a quick introduction of what an ontology is. Ontology, the word ontology means giving meaning to data. Ontology is a structured shared vocabulary that defines concepts and relationships in a specific domain. It gives a common understanding of across the systems and also the people. Uh, Ontology ensures semantically consistency in the data. So for example, if we consider any human language, so most of the language is built on a set of kind of grammar with basically a subject, predicate, and object. So every language is semantically structured, so it can be easily interpreted. And also the ontology enables data integration from multiple sources. And ontology also makes machine reasoning and intelligent search. If a data is represented with ontology, the machines can easily reason the data and also perform search. So to give a quick example, as a human, I can understand the difference of heart attack and myocardial infraction. So both are one and the same. So because I know it, but if we provide this information to a machine, its machine doesn't understand both are same. So if both of these are ontologically represented, then machine can easily interpret this information into one. So, this is one. This slide just gives you a quick information how things look without ontology and how things look with ontology. For example, without ontology, we have assume we have multiple applications running in different devices or different servers. So each of these applications produce data, and it will be stored in different databases of their own. So, and again, as I said, each of the time, this data will be represented in different formats. So this is how the connection looks if there is no common language. So, and then every time, if you want to share data to another system, so there needs to be a wrapper in a programming level to translate the data from one format to another format to make the machine understandable. So if with ontology, what happens is, so it's one common language. So all the applications generate and store the data in one common language, and it can be easily shared to other systems, and it can be interpreted easily by the machines. Okay, now we have this ontology. As I said, ontology is a concept of structuring the data. but ontology itself doesn't tell you how to represent this data in a machine format. So we need a way to represent this ontology concepts in the machines. And for that, we use something called knowledge graph, and using a framework called resource description framework, which is also called as RDF. So the data in RDF is modeled as subject, predicate, and objects, just like a human language, any human language, and we store these values as triples within a database. So each of these entities which we represent using RDF, and then the relationships will have its own universal resource identifiers, which we can easily search through the web and find the metadata information of these entities. So that these triples form a knowledge graph. So this is how a knowledge graph look. Each node in the knowledge graph represents either a subject or an object, and these subjects will be linked to the objects with a certain relationship. For example, here this tensile test analysis generated an elongation, and elongation object, it has a value. Basically here again, elongation is a subject in this case, and it has a value something 27.11. So having this structured way of representation of data make it machine readable, uh, through which we can query and also perform reasoning using the stored data. So this structured way of data, it also enhance FAIR principles, this findable, accessible, and interoperable, reusable. And also this kind of data, we can also call it as AI ready. So most of the time, when we have this data stored as PDF or is in an Excel sheet format, we cannot feed the data into any large language models nowadays to understand and perform reasoning using the data. So it needs to be in a certain format which these large language models understand. So having it in a knowledge graph, it makes it easy for any AI models to go through it and understands and perform reasoning out of it.
Kiran, we have 10-15 minutes for this
Okay,
section.
I am almost done. So ontology is a concept, and we can represent this again. It's in a certain format. We can't directly transform any concept directly into an ontology. There can be different levels of building a vocabulary out from any concept. So, for example, we can just have a controlled vocabulary with certain keywords, which is less expressive. And then we have other way of representing data called glossary, taxonomy, thesaurus, and finally the ontology. So we consider ontology as more as very expressive with a lot of rules and logical formalism. So again, I don't want to go completely detail into the ontology. So there are two ways of creating ontology. One way with top-down approach. The other one is bottom-up approach. So top-down approach, it starts from a broad understanding of the data with high-level concepts and progress to more specific details. So there are certain challenges with top-down approach. Uh, Usually top-down approach takes a lot of time, typically half a year to come up with a ontology concept. And then uh, uh, also it requires ontology experts to perform top-down approach of transferring data into ontology concepts. Some of the advantages are it ensures a consistent framework, and also it brings in advanced features like exams and reasoning. Uh, and then there is this bottom-up approach. It begins with a specific and detailed concepts or instances, and it finally generalizes to a broader categories. The advantages are it can be agile, quick, and it improves the transparency. Some of the challenges are the duplications and inconsistencies in the data. So many users can create this vocabulary or the ontology terms like by duplicating some of the concepts, and it's really hard to identify in the initial stages of creating these terms. So here is an example of a top-down approach, which we did it in our previous project called Reexpro. So there was this already existing MO ontology. From within the Reexpro project, we extended this MO ontology with certain new concepts, and this is how the structure looks like. And also, the most recent one is the Cameo ontology, which we extensively utilize in our process editor tool to document the CHADA. So the Cameo is a top-down ontology-based approach. So Cameo stands for Characterization Method Domain Ontology. It aligns with MO and some of its modules, and it is from it is part of the project called NanoMe Commons, and it serves as the backbone of RDF-based representation of the CHADAs. So for more information, you can go through the paper highlighted in this slide, and also the GitHub repository for Cameo. So I mentioned about a lot of ontologies till now. There can be thousands of ontology across different domains. For example, we have Cameo, we have MO, RDFS, DC terms, FOF, OWL, and so on. Each of these organization creates these organizations and store it separately on the web. But there needs to be a way to bring these concepts or ontology terms into one single place and organizes them so that we can use these terms, vocabulary terms, somewhere within the experiments. So for that purpose, what we did was we developed this new software component called vocabulary manager, through which we can import the ontology terms or any vocabulary terms stored in an RDF representation format in the web, and we can import it and we can use it within our platform. So the vocabulary manager, it gives the functionality to import the existing terms from standard vocabularies like Dublin core, friend of a friend, MO, and so on. And it also supports periodic updates of the terms specified through the URLs. For example, Cameo, ontology, or MO in future, if they change it, so the system automatically takes the new changes and updates the existing terms. And we can also create a new namespace. For example, we can create a namespace for A4G projects and document some new vocabulary terms, which we consider it as a bottom-up approach. And then finally, once we have all these vocabulary terms, we can search through these terms, and we can utilize these terms to link it to some of the existing data within our platform. Okay, so this is about vocabulary manager. I would now quickly like to demonstrate how the vocabulary manager looks within our platform and what we can do through it. So we have our own platform developed at Fraunhofer IWM. So I'm not going to explain details about the platform because in the later stages of presentation, Yo is going to talk about it. And I directly quickly jump into the vocabulary manager. So this is how the vocabulary manager looks like. We have two views. One is user view and the other one is admin view. I demonstrate the admin view in some time. So in the user view, we can see all the list of namespaces that we have imported right now into our platform. So we have friend of a friend, RDF, MO, and we can also look into these namespaces and we can search for the terms which are defined within the MO. And I have also created one for A4G. I'm just going to demonstrate it now. So, and we also have this admin view where we can import a completely new namespace. For example, I will now import a demo namespace, something called, we have a ontology called pizza. So, which is stored in the web, and we can import all the terms into our platform. So we give a description and some version, and then we give a download URL from where we have to download. So once we give the URL and if we hit save, all the terms from the pizza namespace will be imported into our system. And later we can utilize this ontology or vocabulary terms for mapping or creation of RDF represented data. So this is how we import an existing namespace. This is how we imported the MO, CHEMIO, and other standard ontologies. And also we can create a brand new vocabulary terms which doesn't exist until now in any of the ontologies. For example, for A4G, if we feel there needs to be a new vocabulary terms we want to contribute, so we can create it through the vocabulary manager. For example, we have a use case called Gleeble in the which is part of the A4G project. So now I quickly create a few terms from the Gleeble use case. So right now it's empty. So there are two ways. There are two ways to add terms into the system. One, we can use this UI form to add the terms, and also the other one, we can use an Excel sheet, already created Excel sheet, and we can import it into our platform. So let me quickly add a term which is called Gleeble stroke. So we give the ID and then we give a name for the vocabulary term, and then what kind of term it is, whether it's an ontology class or a object property, data property, or it's any other property. So for this one is a class, and we give a description, and then we give author and other details, and we hit save. Okay. I don't know what happened there, but yeah. So one thing is we can import a, we can directly create a term through the UI form. The other way is we can just import these terms from an Excel sheet. So we have a functionality to download the Excel sheet template from here. So once we download the template, we can open this Excel sheet and we can fill up the new terms. For example, some of the terms which we added from the Gleeble use case looks like this. We have a testing time, force, Gleeble stroke, true stress, true strain, and everything. We fill up the information. Right now, we have only limited set of attributes for each vocabulary term. In future, we are planning to extend it to more look like an ontology term. So once we have it in the Excel sheet, we can upload all the terms in a bulk. And now we see it's imported into system, but it's still not available for the platform to use it because this data is not in an RDF representation format. So once we import as an user, the admin comes into this section, they can view and they can check, okay, if the term makes sense or not. And then only when they finalize, okay, all the terms make sense, then the admin can run the pipeline. And then the background pipeline will be run in our a platform which runs through an Argo workflow. It takes a bit of time, and after certain time, like 3-4 minutes, once the pipeline is successful, all the terms will be imported into the system, and then finally we can use these terms for mapping the data. And this part, I think Yoav is going to explain it in his coming presentation. So this is from the vocabulary manager, and as I said, the usage of vocabulary manager will be shown later. And finally, there is one more slide. Yeah, so there is a Sun workshop happening, a kickoff happening tomorrow on vocabulary definition for domain ontologies in material science and manufacturing. So if any one of you, it's a bottom-up approach of creating the vocabulary terms. If anyone is interested, you can save the link, and I think Joab is also going to send it in the chat. You can register for the workshop, and you can be part of it. So that's it from my presentation. Thank you so much. If you have any questions, please let me know. Otherwise, Yoav will take over with this presentation. Thank you.
Are there
Thank
any
you.
questions so far?
I think that was very, very interesting. So in the next, speaking from the next part of of this Monday, you show exactly where we start for IED Greenest between the SharePoint and this to build it, because we see it's very interesting, but I'm sure there are a lot of partners who have not yet started. So how do we really start? On which platforms do you put this from the SharePoint, or the SharePoint must be organized with a link to this?
Kieran, if I can take that.
Yeah, please take over. Yeah.
What we can do today, we have after the break a bit later, we will have the hands-on session where we can try to experiment with the system. What we will do shortly after, specifically for A4 Greenest and the project work, is that we will have another server running, and then we would ask the partners with explicit instructions to start documenting their use cases and possibly also enter the relevant terms. An email will follow after this meeting, but today it's basically just to we offer a playground. We collect some feedback and we use that to improve the system and also make it available beyond A4 Greenest. So I can already say that whatever we show today, we plan to. So specifically, the two tools that we are presenting in this webinar, the vocabulary manager, what Kieran showed, and the process editor, which I will show now, they will be available for the public. So then they can be tested out and be used. Hopefully that answers the question.
Yeah, sure. So thank you. If you tell it in the beginning, I had some problem to link just a few first minutes. So thanks a lot.
And we have a raised hand.
Yeah.
Yeah. Hi, Yoav. Long time
Hi.
no see.
Yeah.
Put on the camera. Hey. So this new platform that you have for the manager, ontology manager, and all that stuff is, how do you intend that to be used with other platforms? Is this then you want to go here and manage it and then go back to other platforms, or are you thinking of integrating it into as a component, as an application, or what is the intent? For example, if we have a platform and we would like to utilize your manager in some way, how would we do that?
So what you can already do, and that is just to document the terms, and you can export it into. Right now we support into Excel sheet, but I think exporting it into RDF is maybe just a button is missing, but the functionality is there. So you can just use this tool to collect the terms and export it, and then you have the file and you can use it. When it comes to integration with other systems, we have some different projects trying to connect, having let's say a standard API. There is a Python client out there that I can put the link in the chat. It also has interface to the vocabulary, and this can also be used in this way. But there must, let's say that deep integration with external system with that tool is something that we haven't done yet. But of course, it's something that could be very, very interesting to do.
So it's in the roadmap, or it's something that you would add if something were to happen?
I would say that it's our main goal in these tools that we show today is to serve the European community, and if that's of interest, then we can definitely go in this direction. It's mostly depend on the feedback that we get, and signals that for that.
Okay, thank you.
All right. Good. Then I will continue with the next part of the presentation. In the next part, I will discuss the second tool of today's webinar, and this is what we call the process editor tool. So a short introduction to that. The main question of the webinar is how to curate processes in an effective manner. And this was our motivation to develop this tool. And so what is it? It's a web application for documenting processes in a fair and standardized manner. And it lives inside of the bigger ecosystem. We saw the vocabulary manager. I will shortly discuss the knowledge management concept because it's could be useful to understand what's going on. And we also have other modules, namely the apps and executable workflows. And this is particularly useful when we want to take data sets and integrate them into the system, creating the what we call semantic layer, semantic representation of the data. And for that, we can use automatic workflows to do that. But this is more for general information. Specifically, the features of the process editor tool is that the schemas are defined and curated separately. So we have a separation how the process should follow, and this I will show, and then we can curate multiple standards and choose which one we want to apply for our process. For editing the schema, we have a user-friendly interface that we offer to users with elevated rights, similar to what Kiran showed with the vocabulary and how to import vocabulary. So users with some extra rights can do that. And in this case, it would be to edit a schema or to digitalize a schema. We have the visualizations capabilities. This allows us to search processes, and we can also export to RDF. And in the future, we would like to have automatic report generation, so PDF and Word as well. What are the objectives of the tool? So we want to support different kinds of processes. I mentioned at the beginning, we have different kinds. Today we are talking about characterization, but we will also want to use this tool also for modeling tasks, manufacturing, and AI. We want to support the CHADA standard and also other norms. Today we of course show the CHADA. And we want to achieve the fair data representation. We highly focus on user experience, so we understand that different users have different professional backgrounds, and so we try to separate the ontology and programming, so it's not necessary to use the system. We use this tool. We want to enhance the capability of the bigger ecosystem, and possibly a future direction is to use it for doing executable workflows. So before I show it, I would like to have one slide about the management concept. This would be useful for the understanding. We have two types of entities in the system. One is a knowledge type and one is a knowledge item. A knowledge type is used to define a template. So it can have properties and it can define a web form that will be shown to the users, data model, mappings from terms to vocabularies, ontologies. This is more complex, and therefore we let specific users that are experts in this, they can do it so that the system makes sense. And then we have the knowledge item, which are the realization of this template. So we can have multiple items following this type, and they just follow the template that is defined by the type. Also useful to know that a knowledge item serves as a data container in a digital twin, and it has some structure inside, so it has the metadata, the semantic graph, raw data, and whoever is interested is invited to read more in this paper about this detail. And what I will show now is just how this looks like in a very simple example. So I go to the system, I log in, and what I will just do as a short demo is I will create an organization. We have already some built-in knowledge types, as we can see, the organization, the expert. We can also create others. But let's create an organization. In the hands-on session, we look into a scenario for a startup wanting to develop a new e-bike. So let me create an organization for that one. So let's call it Next Gen e-bike. And I can create the item. What we see here is just some kind of a web page to represent this knowledge item. It has an admin view. As an admin, I can edit. I can add an image. I can see it as a member. I don't have the edit functionalities. I can only see. I have an ID, and I can have certain opportunities to add additional information, links to external sources, contact information, summary. I won't go over everything, but just to show how this looks like, I can add attachments, the custom properties. I have a web form that I can fill, and this web form, as I said, is defined by the knowledge type. We'll show this a bit later. And we can see the connections. And this I will also show later. If we go to the search page, I can search for type organization. And I find the one that I just created. All right. Let me go back to the slides. And shift towards the main focus of this session, and this is the process editor. What we're going to do today is we are going to show an example of a tensor test because not all participants may have different backgrounds. So I would like to quickly explain what a tensor test is in material science. So this is the hello world example in material science. And basically it's a mechanical test where we take a sample and we put it in a machine and we just pull it. And as we pull it, we measure the force and other parameters. So those samples, they are being cut from a metal sheet. So we also have this process, sample preparation, and there is a procedure. There are some standards for that. And the shape is, of course, matters. So the geometries also affects the process. So it can be quite complex, and it really goes deep into the material science domain. So we have the samples, we put it in the machine, and here we have the video where we pull and until it breaks, and this gives us some properties. One is the one that are measured directly, applied force, stress, strain, and some properties are calculated in post-processing. We take the measured data and we run some scripts, some kind of, we apply our knowledge and we gain some properties that are useful to characterize the material. So at the end, we want to know how the material behaves, and this test allows us to learn something about the behavior of the material. So with that, we can have a look at the process editor, and I will again switch to the tool. So I will exit this presentation. And I click on the process editor. And what we see here is the process editor app. We have, this is the user view. And what we have here is process type. In this case, we call it characterization campaign. We call it campaign because we recognize that in material science, it's never about one tensile test. It's always multiple ones. So we already want to prepare the ground for the real use cases. We call it campaign, but in this demo, we only show the one specific tensile test. And we have an example ready, and in the hands-on session, I will ask you to create your own examples. And so let me select the one that we have. And what we see here is that we have on the left-hand side is the process layout. And this follows the CWA, the CHADA standard. And if I can quickly open that. So if I just search for CHADA CWA, and there are two editions. One is this is the old one, and the latest one was done in 2025. So published this year, but part of the NanoME Commons project, and it's publicly available. And basically, this document describes how the process of the characterization in general should be structured. It offers a structure as Kiran presented. And what we did, we took the document, we used the admin view, which I will show later, to put this in structure. So for example, we have the rationale. So it's here in the user story and the characterization workflow. So we try to edit in this layout. And then as a user, I can simply click on this rationale, and I have the information. I can see that on the right-hand side, we have the graph, and we have the connections. It's quite complex. That's why for the user, the nice thing here is that you just fill out those forms, you click save, and those connections are being determined already because they were done by the admin. So you don't have to worry so much. And so we can click here, we see the web form, and we continue with the layout. We click on the user story. We can see that it's connected to the rationale. And here we are using the Cameo ontology to connect, to make this connection. So here we see the connection to the vocabulary manager and the ontologies that are in the system. We have the characterization workflow, and then we go deeper into the different sub-steps. So I mentioned this sample extraction. It's a process on its own. We have the opportunity to link to a specific lab where this sample was extracted. We can mention the operator and so on. So we really follow the steps. So we can see that we have already an example here. And that's basically, we follow the different steps. We can see that, for example, the actual measurement, the actual part where the machine pulls the specimen is documented here. So we can see that we have an operator in a lab, and we can see it here. And you can see that the lab is connected. And if you can see here, so there are some instructions. So if you double click on this lab, you go into the knowledge item page. So you see the information. You can see this is kind of a limited view of the lab. You can go into depth, and you can see the connections to the process. Okay. So that will be it. We have the data processing where we take the measurement machine and we compute some properties, and at the end we can have an assessment whether this still we can give some evaluation about it. That's how it looks like. We have some export functionality here. If you want to export it to triples, I can click here, and then I get the RDF of the entire process. The process is also already in the system, and as a small spoiler, I will show some nice Sparkle queries at the end of the benefit of having that. But basically, we can see that all this information that we visualize here, we can export it. PDF and Word are disabled. We don't support it at the moment, but we would like to have it so we can also generate those reports automatically, possibly with plots and some analysis that we can also do plug in automatically. So that's the user view. I want to show quickly the admin view. So this is a bit more advanced, but the main point of the admin view is to show that this structure is flexible, and you have to be a domain expert. You have to know a bit what you're doing, but you don't necessarily have to be a platform developer. You don't have to be a computer scientist, and that's I think very, very important. So if I go to the admin, I click on the knowledge type, and as I mentioned, or let me say it like this, what we see here again builds on this concept of our knowledge management. So everything that here is a knowledge type, and we can see above the name, and then on the parenthesis we see the knowledge. The name is the knowledge. Obviously, what you see here is a knowledge item, and in the parenthesis is the knowledge type. So for example, we have a laboratory. This is a knowledge type, and it has 2 knowledge items, 2 instances, testing lab and metallography lab. And in this interface, I'm able to determine the how the template of this knowledge type. So for example, if I search for the lab, I see that it has a web form, and then I can edit the web form. So I see that this is some sort of, it has a label and a description. I can also decide that it should have, I don't know, let's say an address. So I say it's a type. It can be something else. I can give it some mapping information. So I can say it has some semantics. Sections. This is something else, but yeah, it has semantics, so I can give some mapping information. So here again, we need to maybe know which terms we should use. We can of course also search for ones, but yeah, and then we can give some more information. Measurement unit is not relevant here, but we save it. I can save the form, and now if I just click on the lab and okay, we have a problem here. There is a problem that if we refresh directly, it doesn't work, but I can just find it. So if I click again on this laboratory, I can see that the address was added. So this is nice for admins to have this flexibility in defining the web form and the mappings to the ontology. And then the highlight is the process. So a characterization campaign is also a knowledge type. And now we want to see how define the process schema. So in this case, there is a process schema for this knowledge type. And we can see that it's linked. We can delete the schema, but we can also just unlink it. We can attach to this knowledge type another schema that is in the system or somewhere else. And we can edit this. And how do we edit? The name here is not up to date, but basically what we have here is the interface. Here we select which knowledge types are participating in the process. So we have it there, and there we and now we can add new ones. And if I add a new one, so let's say I decide that laboratory should be there, then I see it in the layout, and then I can define the structure. And if I change it here, then this will affect how this looks like here. And that's the flexibility that is very useful to manage all of this. Let me remove this one. And then the semantic relationships, this is the last part. And this is where, again, the admin decides how those items should be connected. And what we see here is the different knowledge types, and we can use the this interface to make connections. So for example, I decide for whatever reason that data processing should be connected to rationale. Then I make this link. I can decide that it should have, don't know, something, some predicate. And now it's should be there. We can see it here, that it's connected. I can save it. And this means that when the user creates the different items, then the relationship appears automatically. So that's quite nice. I will not save it. I will just close it. That's what I wanted to show in this session. What we have next is, maybe before that, I would like to give some time for questions, and then I can say something more. So yeah, I would be happy to take questions if you have.
Hey Joaf, a quick question: was there a way to upload a graph from some kind of format, or is it manual entry at the moment?
Which type of graph are you referring to?
Well, this
one?
Indeed.
It's possible to upload any RDF to the system. The challenge here is because we have this concept of knowledge type, knowledge item, then this needs to be somehow translated. With the Python with the Python client, it's possible to write such scripts to make this work, but it's not immediate. There is no kind of, let's say, a nice interface to do it. But in principle, you can do it. Yeah.
All right. Thanks.
Sure. Any more questions? Okay. Then what we have next is a break. And I suggest that we meet here at 11. And then we start the hands-on session, and we first have a section for the vocabulary, and then we also try this process editor. So we see each other in a few minutes. Then until then, thank you. Okay, so we are in the hands-on session, and for this we have created some sort of a scenario where we want to develop a still material for our next generation e-bike, and the scenario is as follows: that we have a startup company and designing this e-bike, prioritizing lightweight construction, high durability, excellent safety for urban commuting. So typically that's kind of, when we develop products, we have some requirements, and then we have to select materials that fit to those requirements. And that's the exercise today. We want to build the bike frame, and we're going to have innovative steel for that. And we are considering several yes, we are considering several steel alloys, and we need to characterize them. And we use the tensile test example for that. And we will be focusing on the 316L. Might not be the best choice for that, but for our purposes, it will be enough. So that will be our scenario for today. Maybe some notes before we get going. The plan is that we have until 11:40 this session. So, and then we start with the registration. Hopefully it will be very easy. And then we want to do the vocabulary manager together. And then we shift to the process editor. Maybe some notes. Errors may occur. You have already seen this in the presentation by Kieran. In the meantime, we tested it. For me, it works. So if there are errors, specifically for the process editor, this is really the first time we really try it out. So it might occur. Just heads up. And also, there might be some name conflicts. And what we suggest here is that you just use the letters from your last name as a suffix. So for example, if I create a user story, I can use some letters at the end so that I don't have problems. Important to note that the data that we are storing today is not going to be kept. So it's just for this webinar, and then we're going to delete it. Also refrain from uploading confidential data. It's just a tryout instance for today. If you have one screen, it's maybe you would like to use this Win key and left-right to split the screen. The reason for that is that you would like to have your browser to test something out, and I will still sharing my screen so I can give some tips and show something if needed. That will be it. I would also recommend to open the cameras if you would like. This could be useful for this session, just that we have some more interactive part. And another thing is that during this session, I will also share a poll where you can fill anonymously to give us some feedback, which would be useful for us to analyze later. Okay, so let's go on. So the first thing is the registration, and I will put this link in the chat. Or maybe you can also do it for me. And then I will just ask you to register, and the instructions will be on the screen how to do it. For now, I will continue. The next thing is the vocabulary manager. So how to reach the vocabulary manager, we would like to try it out. How to reach is that we click on the Explorer and we go to the vocabulary. And then there are some tasks that you may want to test. You can review the ontologies. And this, Kieran, if you can also put that link in the chat with the GitHub.
Yeah, I'm doing it now.
So we prepared two documents in a public GitHub repository. One is for the vocabulary part, and the other one is for the process editor part. And in the vocabulary, maybe I can show it. You should be able to follow the link that Kieran put in the chat. You click on the e-bike vocab, and we have some terms that we can fit into the system. So these are the terms, and you can go to the vocabulary, and we have created a namespace, the A4G webinar, and you can try to just add a term using the web form. Hopefully it works. I tested it. It worked for me. but there might be some problems. So let's hope it works okay. In this Markdown, you should also see some explanations about what is a class, what is an object properties, getting a bit technical, but hopefully this explanation is useful. And then we have data properties. So there are some examples here to illustrate what are the differences. So let's give it a try for some minutes. And then, of course, feel free to ask questions. And then we continue with the next part.
If it fails for someone to add the term through the UI, they can also download the Excel sheet and open in their computer. They can fill in the data in the Excel sheet and then upload it back. They can also try this feature as well.
Yes. So we have two ways to enter terms, as Kirill mentioned. One is via the web form and one is via the Excel sheet. And you can try both.
Yeah, the idea of the Excel sheet is, so like we want, like some users, for example, if you are adding terms for like more than 100 terms at one time, the UI doesn't make sense. So that's why we thought, okay, we have this Excel sheet, we can just fill in the data within the Excel sheet, and with a single import, you can directly import all the 100 terms.
In the meantime, I can put in the chat the poll that we created. I can quickly show that if anyone already wants to use the time now, they can. It's possible to start the poll. I will just, but we can also do it later. It's okay. In the meantime, I will go to this, and I can try to refresh, and we see if we have 3 terms. We can see that they are pending. So this means that the admin at this point can review them, decide if they're okay, maybe merge them if they are a repetition.
Maybe you can start the pipeline for these 2 terms so that we can just show them later how the IRI gets generated later.
Then I click on the button, and then we have a pipeline that just takes those terms and push them into, creates RDF from them and push them into the Drupal store. I also put in the chat CWA. So if you would like to review the document, it's also available. Okay, so the pipeline has finished. And we see that they are published in the system and can now be used. Okay, I suggest that we go on. If there are questions, just feel free. But for now, I think we can go to the process editor. So to reach the process editor, you click on the tools on the upper left side of the screen. You then have a drop down and you can click on the process editor. And you select the one characterization campaign that we have there, and you can create your own process by clicking on this plus button, and the information for the process you can simply copy paste from the Markdown file that is also provided in the same GitHub repository. So let me show how this looks like. I click on Tools and Process Editor, and I click on Characterization Process, and I can do my process dash. So, and then I created the process, and here I go back to the root folder of this repository, and I click on the other file, the e-bike process. And what we have here is some sort of a big table. You might need to, there is a scroll bar below, it's a bit hard, but you can see the different elements, and in principle, you can just copy paste the things. You can also try to go beyond what it says. So, for example, if you want to create your own lab, you can click here and you can do my lab, and then you can create knowledge items in this way. That's the exercise for now.
Maybe parallelly you can also create a rationale for your example.
Yeah, I can do that. So the way that I do it, I simply copy paste the description. I put it here. The names, I will call it simply rational mesh. We can think about it later. And the name, in this case, it will be Mariam. So I select her. Let's see if I have more information here. No. Okay, so that's all the information. I save it, and I see something on the screen. And the same I do for the other elements. Okay, so we see how the graph is slowly being populated. And yeah, I think it's important to highlight as a user, we are not too much bothered by the ontology. We just see that it's used, but we don't have this dilemma which relationship I should use, which is useful for if I don't know ontologies. Has anyone encountered any problem or issue? If yes, please let us know.
Not yet.
Great. For the there is a raised hand.
Probably I'm totally non-good in informatic and from another generation, but I even don't know what you call a rationale.
The name, you mean?
The name, yes. What do you want? Because Lucas Morin nicely explained you what you use as term user story, but you must see that a lot of people just don't know just these basic things. So
Yeah.
what do you call rationale?
Yeah, that's a very good feedback, right? It is sort of a dilemma that seems to be hard to fix. I think that in general, maybe there shouldn't be a name here. It can be automatically generated if it makes sense, so that the user don't have to think of such trivial things. At the moment, I agree that it's a bit nonsense what I write here. So it's just rationale.
But if you put question or things that everybody knows, it would be easier. Rationale for me it means nothing.
You mean the yes? So this is again a bit related to the training of how the format works and the specific element that we see here is really coming from how the CHADA is structured. So what we can add here is some information. This is missing, and maybe a link to the standard. This is also missing, but it's either way possible to go to the document and we can find the rationale and simply explain how this looks like. And I think the best term, maybe I can just search for it like this, rationale, and we just go for the first instance. And here is the explanation of the rationale, and basically it's just meant to describe why the characterization approach was chosen for the user story. So in the discussions for defining this structure, they acknowledge that it's very important to document the reason for this approach that we're using for the characterization method, and that's the purpose of this one, is to really give a place to document that. But it's a good note that the name is a bit confusing, and also what is the purpose of what am I supposed to write here?
Okay, it's the reason why you enter your user story and do all the job.
Yes, exactly.
Okay, so thanks. It's just to show you how basic your future user are.
Yeah, just quickly, in a quick info to add. So previously, we also had this information icon next to each of these attributes and also the knowledge type, describing what exactly it is. With our new latest UI design, we have just removed it. But in the coming days, we will also have a link which a user can click, and you can also visualize what exactly the user story is. You can see the description which you have showed here in this document in the web form itself. So that will be available soon. So you can also click on each field, and it describes why do you have to fill this field and what exactly it represents.
Okay, perfect. Thanks.
Okay, hopefully things are going smoothly for the others. Okay, so let's give it just 10 more minutes for trying it out. And then in 11:40, we will simply have a conclusion round. In the meantime, I can, if you have questions,
Yeah.
of course, you can.
Yeah,
Yes.
it started working. It started working now.
Ah, great, great. In the meantime, I will maybe show the poll. We will also give, so this is a poll that we would like to ask you to fill out. It's you can give your background information and overall feedback, the content, and then we have the different tools, if it's applicable, and then if you have wishes and other free text fields. So we would appreciate that. If you are bored with the system, you can already start filling this out, but you can also, of course, do it later. It's just okay. So let me go back to my process here. This could be interesting. So the tensor test dataset has 3 outputs. Okay, it only has there. It's also related to this one process. So if we have multiple processes, we are able to filter out all the other things, and so we can focus on what is interesting for us. All right. Then I suggest we conclude our hands-on session. And Kieran, I will hand it over to you for the last part. There is some question in the chat. Maybe before that we can address it. Yes, the deletion is really a good point. So at the moment, the system doesn't consider it doesn't have a very complex user rights. So we have the roles, the admin and the user, but we don't have user groups inside the system. And this will be one of our next one of our next iterations where we would like to have some sort of user groups. So I have a process just for my group, just for my organization, and they're in the data space, they're in the system, but they are not visible to others. And that means also in the search. And there we also have we can have different visibility. So you can also only view, you can make it public, you can assign who can delete, who cannot delete. This is currently not implemented, but this will be in one of the text iterations very soon, already planned. So thanks for the questions. If there are other questions, please feel free to.
One more thing to add here. So the question he asked was, I think the operation was performed from the process editor app. So I think we already have certain user permissions in the platform level, but the tool which we have developed, process editor, it was actually not part of platform initially. Now we have integrated into the platform, but without complete user permissions checked. So yes, in coming days, of course, we will add these restrictions in the process editor level as well.
Yes. There's another comment. History of the same file. Also interesting point. So what we see here, for example, is we have a data set in the system and we have some sort of a test file. And we can open it and we see this is a typical output file of the measurement machine. You can see that it's in German. And with the integration pipeline, we are able to represent it in the system with ontology concepts. So again, kind of trying to establish one common language. At the moment, there is no history of files. So if you upload a file with the same name, it will just override the one before. So these are some functionalities that we haven't been focusing on, but we can also implement them if there is, as the system getting more and more mature, such requirements will appear, I would imagine, and then they can also be implemented. So I hope this answers the question. Okay. Then I will stop sharing, and Kieran, maybe you can take it over and wrap it up for today.
Sure, Yao. Thank you. Can you see my screen again?
Yes.
Yes.
Okay. Yeah. So before moving to the conclusion, I also wanted to introduce one of our colleague, Matthias Bischelberger. He has joined the call a bit late. He was in the other meeting. Matthias is also responsible, along with me and Yo, for development of our process editor tool and then the vocabulary service. Maybe Matthias, you can say hi.
Hello. Some of you might already know me from other projects. Yeah.
Okay, then. Okay. So let's move on to the conclusion. I hope everyone enjoyed our presentation today and also the demo. We hope it could have went well better, but still we are happy with the way it went. So yeah, here is the conclusion note. We want more digital and fair ways to document process in the material science domain. So today we demonstrated our process editor tool and also the vocabulary manager tool, which is an effort in this direction. So what we presented is a first version of our digital tools. So this will be further enhanced going on. So what we need from all the partners is we want the feedback, like how the tool looks like. Is it helpful for your day-to-day work and within the project? So I think you have already shared this link, a feedback poll. So you can also share your valuable feedback over there, and also you can also maybe you can give feedback immediately, even during the call itself. So that we can further improve our tool going forward. Yeah. Thank you so much.
Can I ask a question about the future? So you develop something that will be useful for our project and for other European projects, surely. But after, if another association wants to use it, you will make it, you will sell it, or how do you see the management process? Because there is work behind, so there must be money behind. So if you have new user, how do you handle it?
Yeah, I can try to answer that. So I want to say from the start that really the main goal here is to really promote to advance the European community, and that is making the tool available, and so it's useful for that purpose. The question about how to finance it, that has been a main question, of course, from our side, since we would like to make it sustainable. And the way that it works is, so I can say that ultimately the business model of this is undetermined. It's open for opportunities, for ideas. Let's say that the fear, we also had considerations to make it open source. So some parts of it are open source. It's in principle possible. The fear is that we are not able to finance it. So finding the right structure is an open question from our side. At the moment, we are doing it via research projects, but with the goal to make it usable and useful for the users. And so we are looking for opportunities, and we are open for ideas. And currently, this is how it's being done.
Well, currently in the group and the different association where I belong, everybody uses the Nodo because it's quite free and efficient. Not as good as you, because CHADA is not so described, but well, there is some README file, and then everybody use it. So you have such competitors, so you have to offer something else, and so that's a real important point in order that all this work is useful.
Absolutely. I think Zenodo is one example. Of course, there are other examples. We have to keep in mind that what we have seen today is coming from, it's also research. It's the research in the area of digitalization for materials and manufacturing. So it's kind of, if you compare it to other system, it's not quite as mature compared to some products. Zenodo would be one example, but with planning and luck, we are able to put something that can give new advantages compared to tools like Zenodo. So if we are, as I mentioned, we plan to have the process editor available for users. Then this can be over time get mature to become more robust and more have more features. So we are still at the beginning, and hopefully we can continue from there and build further.
So thank you. I see more the future. Thanks.
I think more amount of practice is required to understand the system.
Mm-hmm.
Yeah, because this is not a one-day job to do.
So maybe once we open our platform for the A4G users to create CHADA documents later, Maybe we can also have a video created how to do this documentation process, and maybe we can provide it later, right, Yo?
Yeah, and diagnose. Go ahead.
We are still yet to have the actual use cases from the A4G Nest. So the idea for today's presentation is we demonstrate the tool, and from each of the individual use cases, we want our partners to try and use the tool to create their characterization documents, and that would be a real feedback for us. So if you cannot create the actual characterization document from the use case, we can see where we potentially improve this tool. That helps a lot. So I think going forward in a few weeks, once we have this stable version and open for public, not public, but for the A4G partners. I think I'm going to send another email with maybe a video describing how you can clearly create the characterization document. So then you can try it out and give us further feedback.
I can also mention that we plan to do more webinars, and the training material hopefully gets improved over time.
Okay.
Can I?
Please?
Yeah, just a small feedback to you. Like as you mentioned that you're going to create a video, a small clip that how we could upload our data results into this domain. So is it possible to like for you to explicitly said that like, because I'm from an experimental background, so I won't understand modeling that good. So like how an experimentalist can understand the modeling data, the modelers are uploading it, and how we could interact with each other and understand each other's work through this domain. If you could make a video in that way, then that could be highly appreciated.
If I understood correctly, you ask how you want to know how the data model is done for the experiment. Is that correct?
No. Like if I'm going to upload my data, which I got it from my experiments, okay, and if, for example, if any modeler is there who want to understand my data, then how we could understand each other work through this domain, and how we could do it through this domain. We would like to know that thing. Means I would like to know that thing, like through this domain, each other's data, because everybody is using different names and parameters.
So just to make sure that I get the question, so you ask if how to integrate the data into the system.
Yeah. So like I have I have a few microstructures and with me, and I have few data related to global and everything. So through that video which you're going to create, like how to put it in a short video, how to put those data into the system, and how if I wanted to understand what the somebody who is doing some simulations related thing, then how I can compare and how I can take their data to compare my experimental things. So in that way I was asking.
Okay.
In that sense I'm asking.
Okay, we have some tutorials for that. Maybe in the chat we can put some. We didn't show it today. We didn't focus so much on data integration, but we can put some material and then also to have some videos in the future. I don't think we have something at the moment that can be shared now, but we might have. But yeah.
It would
yes.
be perhaps to answer the question of Rishabh that I truly understand. Already providing to the one who put the data, who is uploading them, and that you put a question, why do you upload, which type of model do you use, and which type of result, this give feedback to ReShap to know what's the use, and you could ask question. Please provide a link about your result. In so like Tim, somewhere the simulation result and the data we use either to have the input data and the validation data and our result, we must be easily able to link these things. And if your platform can help in this direction, of course, that's a very good advantage.
Yes. Maybe I can hand it to one of the colleagues to respond. I will just say that we do have such capabilities, but we didn't show them today. I think the question here is about data integration, which was not so much the focus of this webinar, but we can also have more sessions, more materials about this, so we can highlight this point. But it's of course a very needed feature that we also saw previously. But Matthias can say more. Then go ahead, please.
Yeah, so I'm answering here since in the team I have the strongest focus on the data integration. So in the several projects and use cases, of course, we have various types of data formats in different expressivity, in different completeness of the data, and so on and so forth. And there are techniques for making them more barrier-free. For example, one opportunity, as we might have seen today, is our graph representations, because they are machine and human readable. And of course, you need tools in order to make this conversion or translation and representation into knowledge graphs. So we have provided some tools which are open source. So for example, one pipeline is freely available on GitHub, where somebody who's not aware of semantics or how knowledge graphs actually work, but we are able to provide semantic mappings where we say, okay, this specific entry within my Excel sheet, JSON file, CSV file, whatever file is compliant to a certain vocabulary. I would like to map it to a certain vocabulary, which we have integrated into the platform from your own terms or your top-level ontology, which are available. And then I just need to provide some parser arguments, how to process basically internally within this pipeline, how to read this file, how to extract the values, and of course some extra information. So those packages, so the one example package how to do is what we provide is called data to RDF, but of course there are other pipelines which you're able to integrate, because there are various technologies already available in the web which can do this, but we are open and have the opportunity to integrate them to the platform. And they all, the solution we provide is something which is usable by anybody who knows basic Python. We are also able to provide some this for simple use cases with a end user interface. But if you have more complex data, more data sources, complex data files, you have to go programmatically for now. So somebody who knows basic Python is able to do this without having the need to know how ontologies or knowledge graph actually works. We just need to say, okay, how do I read in the file? I map concepts within my file to classes for my vocabulary, and then you integrate it. Of course, you can automate this with libraries such as Python library, which is an SDK. So we call it's an software development kit, which is able to connect to the platform to push in the data, get it out, basically. So this kind of technologies we offer. I hope this is broadly answering the question.
The link is in the chat for data to RDF. I see that there are some other comments regarding A4G. I suggest to answer that in one of the upcoming project meetings. I think it's a very good question, but we need to discuss internally in the project how to manage everything. Seeing the time, I would like to finish this section of the questions and feedback, and also finish the webinar. So at this point, I would like to thank all of you for participating. Kiran and Matthias for helping today, and also for the preparation, of course. And if you would like to ask more questions, please feel free to do so by emails. We are also available in LinkedIn. We remind the poll would be useful for us. And see you next time. Thank you.
Thank you.
Thank you, Joab.
Thank you.
Thank you all.
Bye.
Thank you.
Bye.
Thank you. Bye.
Bye.